Hello everyone, today we have a quick video talking about the different distance time graph, velocity time graph, and the acceleration time graphs. So let's say that you have this graph right here, and this is your distance, okay? And this is going to be your time. And so let's say that your distance graph looked something like that, okay? So here you have the distance on the y-axis and you have the time on the t-axis, let's say. So this is going to be a change. However, so what's going to happen here is that you're going to see you have a distance and a time. And we know the concept of a slope that we talked about in a different video, that we have the rise over the run. And so the rise is the y over the t. And so this is equal to, because they corresponds to the distance over my time. And so we know that distance over time is equal to speed. Okay, so then my speed is equal to distance over time. So how does that mean? Well, that means that your speed is also equal to the slope, because the slope is equal to rise over run, equals y over t, equals distance over time, equals speed. So the speed is equal to slope. Pretty simple, okay? So we're going to have here, okay, so what's the slope at this point? That's your speed. What's your slope at this point? That's your speed at that point. What's your slope at this point? Well, that's your speed at that point. It's very close and it only touches the graph at only one point. And that is what we have to know, the instantaneous velocity at some point. So instantaneous velocity. And that is very important. A lot of applications happens. And for example, you have to know when a person speeds over the speed limit. Okay, so that helps us to know at a certain point of time what was his speed, because he moved a certain distance in a certain time period, and that's going to give us his speed, right? Okay, so we have this right here. Okay, so we know that your velocity is equal to the distance over time. That's equals to the slope. So let's say that you have a slope, that you have another graph. Now, here you have your velocity. Here you have your time. Now notice, we had the time it's exactly the same, didn't change. Why is that? Well, because we're depending on time as we move through, right? So we're saying at some point of time, and let's say that's your speed. Your speed as a constant line, that is because we just got one of these, right? So we said that, okay, so this is my velocity. Boom, it's right here. Velocity, time graph. So nothing changed. The time is still the same, but on the y-axis it changed. So it's now velocity. Okay, on the x-axis, oh, it's still the same, it's time. Okay, well, let's see this. Then, okay, we said previously that the slope is equal to rise over run. Okay, that's interesting. So that's equal to, what do we call it? Let's call it this v, shall we? So v, okay, that's v over t. Okay, so if we used units, here in the distance we had meters, and it's usually for time it's seconds. So, and this is also equals to meters per second. So that just tells you that your speed is equal to meters per second. That's its unit, right? So it tells you the unit and tells you what it is. Here too, so you have the slope, rise over run, v over t. Well, that's also equal to m over s. That's your meters per second. That's over there. Okay, and what else? What's my time? My time is s. Okay, so I have this here. Now what I can do here in very mathematical operations, so s is equal to s over 1. So what I can do here to get this the second denominator, because I have 2, this is 1, this is 2, so I could get rid of that by multiplying by 1 over s. And multiplying by 1 over s, just to get rid of that second denominator. So this and this cancels out. Well, I'm left with, here if you multiply those two, and you multiply those two, you're left with meters per second squared. Okay, so what does meters per second squared equal to? Well, it is equal to the acceleration. So we're saying that the slope is equal to velocity over time. It's equal to the acceleration. That is meters per second squared. Yes, so here we're saying that the slope of the velocity at this point, or at any point, it is the acceleration, right? So that is my acceleration. So okay, so let's have another graph here. So let's say, so if you copy that, it's going to be here. Okay, so now this changes, that's your acceleration. Let's name it A. That's your time, stays the same. The time stays the same because we're depending on time as we go through, right? That's your time, it stays the same. And also, if we notice that we did the same thing, I just wanted you to go and exercise this. Try to do the slope, rise over run. You have A over T and work it out. And then tell me what the slope of the acceleration time graph represents. Okay? So pause the video and try it out. So unpause, well, it is equal to a jerk. So the jerk is the slope of the acceleration time graph. Okay, I hope this was helpful. This is an overview of the slope and its uses in physics. So we're combining calculus and physics in this video. Hope that was helpful, and thank you so much and have a good day.